So I'd like to talk today a little bit about my master's research that I ended last year, and I think it's a nice issue to talk about because we are always analyzing and refactoring our code. So I think it's a good opportunity to talk about it. So I don't know if you know how it works, but every time when we start with a scientific research, we have to think about a problem to be solved. And then when I started this work, I thought about something that was a problem for me for a long time, and as I was working with LabVIEW for many years, I thought that would be nice to talk about codification problems and how to solve these problems to have a better code, a code that could be easy to maintain, to scale, and everything else. And thinking about the problems, the context about it, LabVIEW has some characteristics that is different from other programming languages. One of them is that it comes from a scenario that we have a lot of end users developer that is guys that are not software developers. They are scientists, engineers that are using this programming language to solve problems inside the industry. We have a few scientific papers talking about problems in LabVIEW, of coding in LabVIEW. We have a lot of papers talking about, for example, doing something using LabVIEW or solving an industry problem using LabVIEW, but not about the problems of coding in LabVIEW. And we also have we don't have so much tools to analyze and refactor coding using LabVIEW. So this is the context over this problem context, and then we have to develop some questions to try to answer during this research, and we developed three questions to be solved along this course. And the first one was about the main bad practices that we call in the industry, like the cold smells or bad smells, problems that can impact the life cycle of a LabVIEW application. The second one was the concepts about stat code analysis that could be applied to analyze LabVIEW programs. And the end, why to develop a tool to identify the main programming bad practices in LabVIEW. So we created these three questions to be answered along the master research. And to do this research, we use a method in which we have chosen design science research that is a method that is nice because we can use an artifact to to solve a scientific problem. So we have the context where the problem is inserted. For example, the industry of software, where have the knowledge context that everything that was studied about these problems. And then over this, we design an artifact that can be a framework, that can be a piece of software that we can use to solve the problem that we are researching. So we use this method in our work. And then after that, we passed by a literature review. That is something important to know what the academy, what the scientific field has about this issue. So the systematic review, it follows some rules that avoid that the researcher has a biased view over this. So we try to be not to be partial, because it's common when we are working with a tool that we have some experience. It's very easy to put our view under this part of the work. So the systematic literature review has this objective to avoid a biased view from the researcher. So we selected these papers that would be nice to understand what the academy was researching about code smells, not only LabVIEW, but we have some researches in another languages, for example, but could be useful for our research. And then the main points that we had on this research was a list of the main problems that could be found in LabVIEW. So we have some papers that guys the guys was researching about that. So they created a list of the main problems in LabVIEW. We have another papers that was useful to understand how the structure of the LabVIEW is inside the code, and how the data flow works inside the LabVIEW code. And then to build an artifact to be used to solve our problem in our research, we look for some content about what could be useful for this to analyze a graphical code in LabVIEW. So we saw a little bit about the intermediate representation. We see a little bit about the LLVM, that is how the code is compiled in LabVIEW. But all of this, we didn't find so much information about this concept. So the best way to try to create a piece of software, an application to try to analyze and refactor code for our research was using the VI server and VI scripting tool. It would be easier for us, because as LabVIEW developers, to use this research, we have a lot of information about how it works, and that was the reason why we have chosen this tool. We could create a LabVIEW application that could analyze the code that we are interested to. So we develop a small code that we called in our research the LabCODE analyzer, that it could be analyze some codes that we chose during our tasks there. So we use this this feature that was proposed by these authors, and we have the study done by the researcher. We have some stakeholders here that give some opinion about not the treatment, because this is for medicine research, but for us here it would be like a solution, and we don't have this role here. So the guy that designed and implemented was the researcher. And then our application, we can start the analysis of a code, and then after the analysis, we have some problems that we can show to the guy that is analyzing, so it can highlight the code that it to show the problem that it found. It was found. We have an option to explain that smell, so it goes to a web page that can show an explanation about what is that code smell, what the implications, what the problems that it can bring to the code. And we can refactor. It can make an automatic refactor or a guided refactoring that gives some tips to the user to how to solve that problem. Or even it can skip the smell, just say, okay, I know that it was a smell, and okay, we go forward with this smell because it's the best option that we can have. We can't. It was not feasible to have the code without that code smell. And then after that, we passed by an empirical study to evaluate the tool that we developed. So we have some interview with some guys in a company that has some experience in working with LabVIEW, to see what would be the most important code smells to be analyzed by the tool, because we had to limit this because it was not viable to have all the code smells on that tool. And then we applied a manual analysis to some developers with not so much experience, with guys that had LabVIEW Core 1 and Core 2 one month ago, and then they had the opportunity to analyze 4 codes manually, and after that they could analyze using the LabVIEW the LabCODE analyzer. And after that, we got some feedback from this guy, some suggestions about the tool, what they had feeling about that. And we had selected this 7 code smells for our application to analyze in our codes. And we go to the results of the empirical study. So here, I just can show you how was the results for that. So I'm sorry because I don't have time to pass this to English, but it's in Portuguese, but that's okay. And the developers that used the tool analyzes manually and spent, for example, 19 minutes, almost 16 minutes, 22 minutes, and 12 and 30 minutes here to analyze each of the codes that was proposed. And using the LabCODE, they had a result that was nice. They could analyze it in a very short time, and the results for that they could find more code smells using the tool instead of using just his knowledge about the code smells. They could feedback us with some suggestions. For example, using the tool in on the LabVIEW environment when we are programming, the tool is analyzing the code in a real time, and they comment that the user interface was nice and needs to be used. And another was to share this tool for another guy choosing another companies, maybe to have another result. And just to finish it, we have some limitations about the research. Well, that could be some threats. As I told you at the beginning, we had a low quantity of studies, of papers about LabVIEW codes. Our research just have 4 participants, so in another scenario it could be different, the results. And the company environment that the study was applied is a company that uses LabVIEW to improve some process inside there, but it's not a company that develops LabVIEW every time. So there we have the end user developer. We don't have full-time developers there, so it's something that could be different if we apply this study in another context of company environment. So that's it. Thank you a lot for joining us on this presentation. I don't know, we have some questions here. Well, yes, I have a question from Sam. Yes, Sam, this tool can refactor some codes that automatically, for example, something that can be used to do, for example, if you have a while loop that is not, we don't have a timer inside that, and it's an application that's necessary a timer there. It can insert automatically a wait function there, for example. But there we have some cases that's necessary to the user have to make some changes on the application. So some code smells we have automatic approach, and some we have a semi-automatic, just a recommendation approach. Thank you, guys.
I mean, one thing. Sorry to jump in. I mean, so one thing that would be useful to know is what is the difference between your tool and VI Analyzer?
Well, the VI Analyzer. Okay, we have this part of automatic refactoring. That's something that we feel, I think it's missing on the tool, and that's a good reason to try something about it. And that when you explain the code smells there, with that functionality there, it can be useful for beginners, developers to learn a little bit more about that code smells, about that problem, why would be nice to have another approach instead of that.
All right, thank you.
Nice.
Yeah, thanks for your presentation.